Good morning, friends. In the last lecture, we discussed regarding the alkyl halide compounds, the nomenclature we have seen. Then we talk about the organic magnesium compound, we have seen the example. Then we talk about the carbon nature of the carbon metal bond and its reactivity. Now we have to discuss the types of the organic metallic compounds, that is OMCs. On the basis of the nature of the carbon metal bond, these OMCs means organic metallic compounds can be classified as ionic organometallic compounds, that is ionic OMCs. Second type is the covalent organometallic compound. Third type is compound with the multi-centered bond, and the last type is the pi coordinated OMCs or organometallic compounds. First of all, we talk regarding the ionic OMCs. These ionic OMCs are the compounds which are formed by highly electropositive alkali and alkaline earth metal except lithium, beryllium and magnesium. Got this right? What is that? These are the compounds formed by highly electropositive alkali and alkaline earth metal except that lithium, beryllium and magnesium. The bonding electron, what is there? The bonding electron of the carbon metal bond are attracted towards organic group, making the bond highly polar. Yesterday I said, what will happen? Carbon will act as the nucleophile, whereas the metal will carry the positive charge, carbon will carry the delta negative charge. Here, the metals are nothing but a sodium, potassium and a calcium. These are the highly electropositive alkali metals. These compounds behaves like the salt and soluble in the polar solvent. They are highly reactive and shows the nucleophilic character. Example is given phenyl sodium, then acetylide sodium. These are the few example is given. These are called as the ionic OMCs. Got this point? What is there in the ionic OMCs? There should be ionic bond. That's the very loud and clear. There should be the ionic bond. And you know how the ionic bond is formed? When the highly electropositive element or some metal will make the bond with any species, at that time that bond behaves as the ionic bond. That you should know. Got this point? Then covalent OMCs. These are the compounds from with the electropositive metal like aluminum, zinc, magnesium, etc. A covalent bond is formed between the carbon and a metal which has two electrons between the atoms. Hence, carbon metal bond are partially polar. Here the delta negative and delta positive charge is there. The polarity of the bond, particularly the polarity of this bond, depends on the difference between the electronegativity of the carbon and the metal atoms. These compounds are less active and less soluble than the ionic OMCs. Example is given, Grignard reagent is there. Grignard reagent, you can take this particular CH3, that RMGX in general, you can take any example. Then iodomethyl zinc, or say methyl zinc iodide, you can say methyl zinc iodide, you can see iodomethyl zinc or zinc methyl iodide, what you can name. Then diethyl, the diethyl zinc is there, C2H5 twice Zn. These are the few examples. Compounds with the multi-centered bond. These compounds are the intermediate between ionic OMCs and the covalent OMCs. The bonding in this compound is not conventional as a two electrons two center type. Means the bonding is not the ordinary type like the two electrons are involved and two centers are there. They involve three centered bond and they are electron deficient in nature. Hence they are also called as non-classically bonded OMCs. Compound with the multi-centered bond is also called as a non-classically bonded organometallics compounds or say non-classically bonded OMCs. Example is given dimetric trialkyl aluminum. Here you can see three alkyl groups are there. These alkyl aluminum will form the partial bond with this particular R. Same way this aluminum will form the partial bond with this R. They form the dimer. Dimer means two monomeric units are there. That's why it is a dimer. Dimeric trialkyl aluminum is the example of this particular compound. Got this point? I will revise again. Then pi coordinate OMCs, the benzoid and the non-benzoid aromatic compound has delocalized pi electron. Hence, that pi electron with lone pair of electron can coordinate with the transition metal ion, forming a complex. This pi electron and the lone pair of the electrons can coordinate with the transition metal ion, forming a complex. Hence, this compound possesses coordinate bond between carbon and the metal. In case of the cyclic compound, the metal atom lies between the two rings, hence they are also called as sandwich compound. Example is given ferrocene and the benzene chromate, bis benzene chromate. Ferrocene, in that ferrocene there is the cyclopentyl ring is there. Okay, in between two cyclopentyl ring Fe is enclosed, that is a sandwich. Here cyclohexyl ring, that benzene, two benzene rings are there. In between this particular, here this cyclopentadienyl, okay, cyclopentadienyl rings are there. In between that Fe is there, okay, because there should be the pi electron should be there. Here the pi electrons are there. These are the cyclopentadienyl rings. There will be the delocalization of electron because two alternate double bond will be there, and that they will share it for formation of the coordinate bond. Okay. First of all, we have seen the ionic, that particular OMCs, very simple. These are formed by highly electropositive alkali and alkaline earth metal, that you have to remember, except the lithium, beryllium and magnesium. The bonding electron of the carbon metal bonds are attracted towards the organic group, making the bond highly polar. You see, on the carbon delta minus charge will be there, on the metal delta positive charge will be there. Metal like the sodium, potassium, calcium, highly electropositive elements are there. These compounds behave like the salt and the soluble in the polar solvent. They are highly reactive and shows the nucleophilic character. Example is given. What is example? What is there? Phenyl sodium means benzene ring is there, and to that benzene ring sodium is attached. One of the hydrogen of this benzene ring has been replaced by this particular sodium. That's why it is called as a phenyl sodium or say benzene sodium, benzyl sodium. Then SC triple bond CNA means, you know, acetylene is there, triple bond alkyne is there, that's why acetylide sodium. Then the covalent OMCs, these are the compounds formed with electropositive metal like the aluminum, zinc, magnesium, etc. Equivalent bond is formed between carbon and a metal which has two electrons between the atoms. Hence, carbon metal bonds are partially polar. Here, covalent nature, that's why it is a partially polar. Then the same charges, carbon will carry the delta negative charge, metal will carry the delta positive charge. The polarity of the bond depends on the difference between the electropositivity of the carbon and the metal atoms. These compounds are electronegativity of the carbon and the metal atoms. These compounds are less active and less soluble than the ionic OMCs. Example is given. Grignard reagent is there, iodomethyl zinc iodide is there, diethyl zinc is there, likewise. Now compounds with multi-centered bond. These compounds are intermediate between ionic and that particular covalent OMCs. The bonding in this compound is not conventional as a 2 electron 2 centered type. They involve 3 centered bond and they are electron deficient in nature. Hence they are also called as non-classically bonded OMCs. Remember this. Why they are called as a non-classically bonded OMCs? Because in the classically bonded OMCs there is the 2 electron 2 centered system is there. Here out of these apart from this there will be the random non-classical bonding will be there. Okay. Example is given. Dimeric. Here dimetric, not dimeric. Dimeric, dimer means 2 units are there. Okay, of the trialkyl aluminium. Dimeric trialkyl aluminium. In the pi coordinated OMCs, the benzoid and the non-benzoid aromatic compound has delocalized pi electron. This pi electron and lone pair of the electron can coordinate with the transition metal ion, forming a complex. Hence, these compounds possess coordinate bond between the carbon and the metal. That you have to remember. Here, the example is given. This particular cyclic compound has been given. The metal atoms is lined between the 2 rings. Hence, they are also called as the sandwich compound. See here. This is a cyclopentadienyl ring is there. You can see in that dotted circle has been shown due to the delocalization of the electron, delocalized pi electrons. It is called as the delocalized pi electron, which will form the coordinate bond, means they will share the lone pair for the formation of the bond with the metal atom. That's why it is called as the coordinate bond. You know, in the complexes, generally that bond is the coordinate bond. How that coordinate bond forms? Here we have seen the example. Some organometallic compounds are having the ionic bond, some are having the covalent bond, some having the that your multi-centered bond, and some will have the pi coordinated bond. Okay, I think so you got this concept well. And the preparation of the organometallic compounds OMCs from the alkyl halide. In generally, alkyl halide we are taking it as a RX plus Mg in presence of the dry ether at 35 degrees centigrade. It gives you RMgX. You can take any example, whatever you want for your purposes. In exam, that Rx may vary. Instead of Rx, there will be ethyl bromide, ethyl chloride, methyl bromide, methyl iodide, methyl chloride. Likewise, that example will be there. Here, the few of them example will be there, but you can take any alkyl halide along with the magnesium in presence of the dry ether at 35 degrees centigrade. You will get formation of the RMgX. This is the preparation of the Grignard reagent. There is a bromomethane or so you can take the methyl bromide plus Mg, it will give you the methyl magnesium bromide. Another example is there, C2H5I plus, means that is iodoethane, or you can call it as a ethyl iodide plus Mg in presence of the dry ether at the 35 degree centigrade, it will give you the C2H5MgI, that is the ethyl magnesium iodide. So many examples. Compound containing at least one chemical bond between the carbon atom and carbon atom of organic compound and a metal. Okay. Then here cyclohexyl chloride is given, or say chlorocyclohexane plus magnesium in presence of the dry ether at 35 degree centigrade, it will give you the formation of that particular cyclohexyl magnesium chloride. From aryl halide, this we have seen about this particular your what we can say alkyl halide. Now we have to talk about the aryl halide. Aryl halide, same general example. Yeah, somewhere it is mentioned like the AR will be there, or the somewhere R, simply R will nothing but the alkyl aryl group, RX plus Mg. Here we have to change, instead of this particular dry ether we are going to take the THF. THF is nothing but the tetrahydrofuran. 65 degree centigrade temperature should be there, it will give you the RMgX, means that particular aryl magnesium halide. Here example is there, phenyl bromide has been taken, or say bromobenzene you can call it, plus magnesium in presence of the THF, it will give you the formation of phenyl magnesium bromide. Got these reactions? Very simple these are. This is the preparation of this particular organomagnesium compound, or so you can call it as organic metallic compounds from the alkyl halide. Simply the reaction is the Rx plus Mg in presence of the dry ether at the 35 degree centigrade, it will give you RMgX. Examples we have seen, you can take the any example. For the R you can take the cyclohexyl, cyclopentyl, cyclobutyl, like that. These are the cyclic compound in the from the alkyl. You can take the ethyl, methyl, ethyl, propyl, butyl, pentyl, likewise what you want that you can take here for the example of this particular alkyl halide, and you will get the corresponding Grignard reagent, or so you can call it as a organomagnesium compound. Got this point? Very simple it is. These reactions are very simple. You can see here Rx plus Mg in presence of the dry ether at the 35 degree centigrade, it will give you the RMgX. You can take any group Rx. Similarly here from the aryl halide you have to take this particular Rx plus Mg in presence of the THF at 65 degree centigrade, it will give you the formation of the aryl magnesium halide. What we called aryl magnesium halide, and there we called alkyl magnesium halide. These are called as the Grignard reagent, commonly known as the Grignard reagent. Got this point? Very simple preparative methods are there. Please practice it well. Any example you can take in the reaction, any R will be there. There is no bar in the book, in the notes we have taken the few example, but there is a chances of coming any question based on this particular part. Got this point? We'll stop here. The next part we will continue in the next lecture. Please go through this lecture well. If we are having any doubt, any problem regarding this topic, you can freely ask me. Thank you.